Hello and welcome. My name is Ajay Naik.
And I'm Manasvi Priyadarshi.
And you are watching UI 5CN webinar. So this webinar has a very interesting topic, and the topic is relevant to nowadays coming tech trends, which is machine learning and AI, artificial intelligence. And we already have migrated to big data and cloud computing, and now is the time where we take those capability and build application which are smart.
Yeah. Exactly.
So in future also we will be having a lot of automation, and we will be actually seeing a lot of job cuts as well.
Yes.
And a lot of addition or new requirements
will be created too for automating those processes.
So more of the automation will happen, and so much of automation skills will be required to actually automate the processes and like streamline the processes as per industry standard, reduce the or optimize those like process which are there in the industry, and that requires a powerful programming language with the capability to do that.
Yes.
And the discussion for today is there are so many programming language which is kind of used now
for
have the capability.
Yes.
Is Python the number one in that?
Okay.
And we will go deep in the library level as well, and discussing like what are the other libraries present which has capability to compete with Python, and why, or if we are thinking that Python is the best library to do that, then why we are thinking that. So let's go ahead and start with understanding what are all the libraries which can build or have the inbuilt capability to implement the machine learning and AI capabilities.
So like before going there, let's look at which languages are currently being used for machine learning implementation, and like what are the top languages that the people all around the world are using nowadays. So as you can see, we have Python, we have MATLAB, we have R, we have Java, we have C and C++, because like even though they are low-level languages, but they're pretty flexible, and they are very fast in doing stuff. So these are the top languages that are being used nowadays for machine learning. And let's see why Python is the best among them. Or is it?
So so I have seen people when they want to really build something custom, they switch to MATLAB.
Yes.
And then when they are in a hurry of delivering something, they use the inbuilt library. Maybe it was built with Python or maybe R. I think R and Python are like the closest rival in that.
True.
But let's look into the capability of Python. Before that, I think we will just first tell you the sequence of the webinar, which will be first we will look into the Python machine learning libraries. Then we will answer the question, is Python better for machine learning, which is the future of programming then? And then what is the bottleneck in that?
Yes.
If it is kind of yes. So most of the future work is going to be automation, and machine learning and AI capabilities should be present in any language which provides those capabilities. So in this case, why Python, or what are the things which is already present in the Python which you can use for the automation currently which is going on?
True.
So let's start with machine learning libraries present in the Python.
So let's look into few of the most used Python machine learning libraries.
Yeah.
So as you can see, we have TensorFlow, we have Scikit-Learn, we have Theano, we have PyLearn 2, we have Pyevolve. We have a lots of others too, but these are the 5 that I have seen people use a lot in their area of research. And let's go ahead and talk about each of those one by one. I'll just go ahead and give you a brief introduction about all of them. And I'll also show you their official API documentation so that you are able to like use it.
Specifically when you are talking about these libraries, then we will also discuss why they are actually used or present, and how basically you can use them or utilize them. Because they are, if you go into machine learning, this is most of the theory part is there, is linked with the computation and mathematics. And then the implementation part is where you link it with a function or use case. Correct. So in this scenario, I think we will understand why that library is created, and also like in a very brief introduction of how to implement it.
True. So you can just switch to my screen.
Yeah.
Okay. So as you can see, the first one is TensorFlow. So TensorFlow is basically one of the libraries that has been made for deep learning and neural network solutions.
Yeah.
So TensorFlow is basically a very high level library where it exposes APIs to you that you can use to program really complex solutions using this. So the way it happens is you create a data flow graph, and data flow graph is basically used for solving those like really complex problems. You make a network architecture using it, and then you apply some kind of a computation on it.
Yeah.
So
I think one question which I would like to ask is, commonly when I think we were also working on machine learning problems,
yes,
we were mostly focused on graph algorithms.
Yes.
And because when we talk about real networks, then or maybe I think any structured data, if we put in if you are using algorithms like Bayesian,
yes,
then we have to actually use graph. Is it because of that, or it is just because it can only solve the problems which can be implemented like or mapped like a graph?
No, neural networks are basically kind of networks only, right?
Yeah.
It's a replica of how our brain has neural networks.
Okay, yeah.
So that's why we represent it as a graph, and then we solve those problems, the classification or regression problems on that, on top of that. So a very good thing about TensorFlow is it's implemented in C++ in the low level. And since C++ is a very low level language, it's really fast. So you don't have to compromise with performance here. So if you are using TensorFlow library, then you are not giving up on performance.
Okay.
So since we have C++ underlying and it has bindings with Python, so you can just use it with the Python APIs.
Yeah.
Okay.
So I think TensorFlow is to go in TensorFlow, you can go into tensorflow.org. Yes. And then API document I think it's open source, correct?
It's open source. And okay, it was originally created for Google Brain project.
Yeah.
So you can go ahead and check out the Google Brain project. It's basically the research team of Google that works on deep learning. But then a lot of other developers adopted this library, and it has been very popular among them.
Yeah.
So you can just see this API documentation of TensorFlow, and currently it supports 4 languages. So it's Python, C++, Java, and Go.
Yeah.
And since we are talking about Python, you can just click on Python, and you'll be able to see a list of all the functions that TensorFlow provides you with.
Yeah.
And as you can see, there's a lot of them. You can see the scroll bar is really small here.
Yeah, it's very small.
So, to learn more about them, you can just go ahead and click on one of these, and it will give you a brief about what exactly does this function do.
Yeah.
And okay, one more thing that I would like to add for TensorFlow is, the learning curve can be a bit steep for this one, but it will be time worth spent if you are able to crack into it, and if you are able to use it without any problems.
Okay, yeah. So I think this is the first library. So mostly when there's a problem of neural networking, then TensorFlow will be the good library for a Python developer.
Yes.
And then even if you are having Java, Go, C++, you can use it.
Yes, you can use them too. But if you are new to programming, then we would suggest Python, because Python doesn't have any learning curve as such.
Yeah. So you can actually start to code Python within like few weeks of your learning.
Yes.
Okay, so let's move on to the second library, which is Scikit-Learn.
So Scikit-Learn is basically
Scikit-Learn.
Science and Kit.
Yeah.
Scikit-Learn. So Scikit-Learn is currently one of the most popular ones. Because it is an all-rounder, you can say.
Okay.
So not just deep learning or neural networks, it is suitable for each and every kind of machine learning implementations. So you can use it. It's an all-rounder, and it's one of the best libraries to use, and it's very simple to use actually. And if you go and look into its documentation, we have tutorials here too, and you can just go ahead and check like how to do what. It gives you support for supervised learning, it gives you support for unsupervised learning, and the best thing about it is built on top of very popular Python libraries like NumPy or SciPy, and it also supports matplotlib. So you can visualize them, and NumPy and SciPy are libraries that basically helps you do a very large computation. So you'll be able to do huge computations in a very short amount of time, and it's all written inside Scikit-Learn. But the thing is, inside Scikit-Learn, everything is kind of a black box. So you can't customize a lot of things in here.
So basically Scikit-Learn is written in Python itself?
Yeah, it's written in Python itself.
So maybe I think they might have used some of the concept which short circuit things or maybe optimize it.
Yes.
So basically what happens if you're trying to customize any library, then the team which have built those libraries, they have actually researched it a lot, and then when they come up with this fine library, then you as a developer, you try to hack the libraries.
Yes.
And it takes a lot of effort to understand why it is done that way. Maybe you are trying to do something which you may not understand, and you break the proper libraries working functioning properly, and then you break that as well.
Yes.
So those things I think they might have, they try to avoid, so they don't give the capability for you to really customize or maybe further extend it.
True, but then it kind of does everything, and it does everything really perfectly. So because I have personally used this library, and I have had a great time using this library.
Scikit-Learn.
Yeah, Scikit-Learn. Okay.
So I think the next library which we will see is Theano.
Theano. So
one thing which I would like to understand here is when you are talking about so many libraries in a project, do I have to use all of them at once, or like only one should I pick, or like one?
Well, you can analyze the project. And based on what kind of computation do you need to do, you can choose the best suited library. Maybe you can choose two of them if one of them is not satisfying your requirements. But mostly, if you analyze it very nicely, then you'll be able to know which library to use. And you'll mostly stick with just one rather than going for all of them.
Okay, so I think if I'm loading two libraries, will there be any issues, because the same thing can be done by two libraries?
Well, I don't see why the issue would be there, because both are independent of each other, and both will be giving their own functions. The issue might come if they are sharing some kind of a document. And if one of the libraries is giving the output in some format, and the other library they take the input in some other format, then the clash might be there, and you might have to take care of it manually to avoid those kind of conflicts.
Because some of the libraries which are built with jQuery, they are having a different variety of jQuery given, and then when you add jQuery, then your functionality is a little confusing, like which jQuery capabilities you want to implement. There are wrappers written. You're using those libraries which are inbuilt having a wrapper around jQuery, and then if you are using native jQuery, the normal jQuery, then the library is confused.
There is a bit of conflict.
Exactly.
But if they don't have the same class name or the same function name, then the conflict might not be there. But if they have, then you'll specifically have to take care of which one are you using. So that's where you have to be careful.
Okay, so let's move on to Theano. I think Theano mainly works on maths operation.
Theano is also for deep learning and neural networking, basically. So the good thing about Theano is you can define, optimize, and evaluate mathematical expressions that involve multi-dimensional arrays. So I might be using 1D or 2D array, but when it goes beyond that, it's like really tough to like imagine it in your mind and then do the computation there. But this library, it just does it. It just does it. So, well, it has got a lot of features, and as you can see in the documentation page itself, it has given out a lot of points why it is so good. So it has very tight integration with NumPy. So NumPy is the library that is used for computation and all. So it's a very good library and very widely used. And it does a transparent use of a GPU too.
So when you're talking about computation, what kind of problem will be considered as a computation problem?
So, say image processing.
Okay.
We have so many pixels there.
Also video processing
processing would also be a part of it.
So we partner with PubNub, and then there were some of the companies which were actually using the video stream, and then on a near real time basis, they were processing the video and then finding out a company name out of it. For example, if there is a video stream going on, and they will find out if a logo of a company is present in the video stream, and so they suddenly do some activity. So there was a use case where one camera was shown, and it was recording all the video feeds. And if a Mercedes car comes, I don't know if it's a Mercedes or Ferrari,
it would identify automatically.
And then it will identify automatically and show a good message that thank you for purchasing the car. And so the customer will feel very good.
That's a nice use case there.
So I think some of the use cases were used where the streaming video will have capability to find out a particular image pattern and then do some activity from it.
That would be really a high computation job because you'll have to do a lot of maths there. So yes, that is what you would consider as like really high computationally intensive job. So maybe you can use Theano to like process all those computation really fast, and since it uses GPU, so GPU is obviously like a lot faster than CPU. So
GPUs stand for graphic processing unit.
Yes.
So people, I think it's a basic thing, but then there are always doubts. And GPU basically are designed in such a fashion that it is optimized for high computation.
True.
Because graphical intensive, the games we are playing.
The games that we are playing, they run on GPU, and it's very intensive in computation.
Exactly. So basically, when you are saying it uses GPU or it can use GPU or it only runs in GPU?
No, it can use GPU too. So, well, you have a choice for that. No one like restricts you to use GPU. And then again, it is really what do I say? Accurate. So as you can see, they have also said that it can give you a right answer for log of 1 plus x even when x is like really small. So these are the things where a lot of programming language lack. And since Python is precision, and since Python is like only like limited by the hardware capability. So maybe the implementation can be done on Python rightly, and Theano as of now is only supported in Python. So as you can see, it's straight away written here, Theano is a Python library.
So I think if you want to use Theano, then you can only use it within the Python.
With Python.
Okay, so that's pretty good. I think I'm very impressed by Theano because most of the computation are AI-based computation, and when we are trying to like implement those, I think most of the automation work requires some of the image processing capabilities. And is inbuilt a matrix multiplication or challenges which involves maths operations, and I think Theano might have a much wider role there.
Yes, and it has got an edge, no doubt about it.
So I think Theano is like going to be my favorite because blue and grey color is also UFF same color. And one more thing, we are streaming live. If you have any questions specific to your use case as also, or any question in general regarding Python or our bundles or why like we are covering machine learning when our basic courses are what we are actually delivering the platform, because this machine learning is going to be the future, and then the coming courses are also going to be machine learning or on-demand skills which are required in the marketplace. So if you are having any questions, any queries, you can ask in the streaming platform of YouTube as well. We will pick it up and answer from our side.
Yes.
So let's move on to the next library, which is Pyelearn.
Pyelearn 2.
Pyelearn 2.
Yes. Okay. So I guess they had Pyelearn and then they went to Pyelearn 2. So, okay. So
it's like Angular 3 they skipped, and then
they skipped Angular 3.
So yeah.
So anyway, Pyelearn 2 is like very similar to what Scikit-Learn is, but the only difference that is between both of them is that was a black box. It is not. So you can write a lot of customized codes here.
Okay. So you cannot really customize inside Scikit, but then from a performance aspect, is it the same performance?
Yes, it would give you a similar performance, but as of now, Pyelearn 2, like they have stopped development of Pyelearn 2.
Yeah.
It is still in use, but they, as you can see, this project does not have any current developers. So unless someone picks it up, it is not going to go any further. But like till the time it was being developed.
Yeah. So basically, the open source community has kind of abandoned it. So all of a sudden, I don't know much about it, but basically, you can pick it up and then maybe add part 3. Part maybe 4, like what Angular has done. Even numbers are like lucky for adoption. So so this library, it is not having any developer community support till now, what we see, but it provides a customizable capability over Scikit-Learn. What I see.
You can customize it more, if not 100%.
Yeah.
You can customize it more. And it's great if you are a fan of writing custom codes and you want everything to be in your own control. So you can go ahead and use this one.
Yeah.
And moving on to like...
So Pyevolve. So Pyevolve is, I think we are covering Py at the end.
Yes.
So this is like evolved version of Python.
No. Evolve because it is mostly used for genetic algorithms.
Okay. Specifically to
specifically for biomedical or bioengineering field.
Yeah.
So, to give you a brief about what genetic algorithm is.
Yeah.
So you have a neural network and you apply some kind of a computation.
Yeah.
And from that computation, you have a function that will give you some score.
Okay.
Some score. So once you get the score, you do some changes in the network, like very small, slight changes in the network, and reapply the computation. And you do this till you get the best score, and then the network for which you got the best score, you use it as a parent.
Okay. Yeah.
For the next generation of programming.
Okay. So basically, you are kind of that is actually learning.
Yes.
So you are basically reaching to a optimum value and then taking it as a universal truth and then kind of going to the next level and saying, okay, this is what I know now.
Yes.
So because see, a machine should understand what is the instruction or the baseline to which it should follow. And now those baselines, if they are changed by the program itself, the learning capability is what it is. So I've written a program of pinging me a hi message, and then those are line of code. But if the code changes itself, and that the code is actually the baseline here, and then if the code actually changes, then it's actually done with some of the inputs.
Yes.
So machine is actually changing that particular line of code.
It has its own feedback mechanism. It gets some output, it refeeds it into itself as an input, and then it changes something, and that's how it goes.
Yeah. So basically, this Pyevolve is genetic algorithm. Genetic means here mostly neural network.
Genetic means like just like generation's parent, and then they have child. Like what would be the best configuration for the DNA or something? Since I'm not from that field, I won't be saying. I would be saying a lot of things wrong, but it's related to that, something like DNA modeling and that field.
Yeah. So specifically to that functional domain, we have Pyevolve to use. I think they specific to any domain. If we have a library, then they might have considered, or maybe there's a demand for that particular functional field to have inbuilt capability within machine learning, so they have used it.
Yes.
I think, and I also have not worked on any of the projects, but then I think there are like DNA samples which are huge, and then you have to kind of understand those. So maybe for those requirements, we specifically use Pyevolve.
Yeah. I like the logo.
Yeah, it's kind of a lizard.
It, I guess.
Okay, so I think this is specific to functional field of genetic. Let's move on to the next libraries, or now we conclude. So basically, these are like 5 more commonly used libraries.
One of the most commonly used libraries, and if you ask someone from a data science or data analytics background, they would certainly name these libraries if they are working on Python specifically.
So basically, the main idea for any libraries to be adopted is, first of all, how easy it's to use, and second, what is the richness of the library.
Yes.
That is like the 2 main criteria which I will prefer. And the third is like how better it does something, so you don't take or consume much resources computation wise, or you give the result very fast. Or performance of the library. So based on all these criterias, Python is basically a high level language. And because it's a high level language, it is slow. But the capabilities which is provided by all these libraries makes Python a very attractive programming language.
Strong one too, because many of them have underlying implementations in some other low-level languages that are like really compatible with Python, and that kind of takes away that issue of speed. So it's fast in itself. So even if you are using these libraries, it will be fast.
So I think that concludes maybe one of the parts of our confusion, because but from now, when we are talking about implementation wise, we also need to consider the competitors.
Yes.
We have R, and we have Java,
and
MATLAB. But when I'm deploying it as a web application, I don't know if we can use MATLAB as a web application.
Well, we can use it in the backend for
triggering a process.
Just triggering a process and having our job done. But we cannot really have a server all written in MATLAB. It wouldn't serve REST APIs.
Maybe someone has hacked into that as well. But from our awareness, it's kind of very unlikely. Also, I think MATLAB is one. I think R is one. Where we have, I think if we say any very near competitor in future for Python, it is basically R. Maybe not Java also, or C++ or C. It's R actually.
It's R. The edge that it has over Python is the capability it has built in for visualization of data. So Python by itself cannot give you any kind of visualization, because at the end of the day, the results, you won't be going through it manually. You'll be seeing it in some kind of a graph or a chart, right? So R has it inbuilt, Python doesn't. So that is one of the places where R has an edge over Python. But apart from that, they go head to head with each other.
Okay, so also when we talk about the future bottlenecks and the problem which can come into picture, so what do you think are the problems which might be?
Okay, so the 3 major problems that we have, we don't have a lot of space, because the amount of data generated is so much that many of the players, if you're not as big as some really big companies, then you don't have that much money to have all those storage spaces. But if your business is so good that you're getting TBs of data per second.
TBs of per second?
GBs or TBs of data per second. You should have storage capacity of that sort. Okay, well, I am able to store it in some place, right? And if you run short of it, then maybe two of the things that you can do is like lose some of the data that you feel is not important now, but it might be important in future.
Yeah.
But okay, that would limit you from doing a lot of things though.
Yeah, I think one challenge or maybe one of the solution to solve this challenge is archiving the data, because even the bank transactions or the dashboards, you might see that some of the transactions has been archived, and that is a very common way of how the data is stored. They only take care of maybe 1 or 2 months data, which is kind of a hot data source, and then there's a cold data source where they put it there. The retrieval and like putting the data there and updating or retrieval is slow there, but it is still there.
But what if you see it like this? Okay, say you have 4 GB of space, 4 TB of space.
Yeah.
Well, it's just a very unrealistic scenario because no one would have just 4 TB of space. But the data that you have got is 5 TB.
Yeah.
Then you cannot really store it there.
Yeah.
Like even you can't even archive it.
Yeah.
That extra 1 TB of data.
Yeah.
So that is one of the issues, because the data generated nowadays is huge. It's just huge. And then the second problem is like computation time.
Okay.
So the time it takes to process all those data is
large.
Is a lot, and like many ways are being employed where you have like really fast processors, or you are building your own chipsets where you have parallel processing capabilities.
Yeah.
But even with those, the inflow is so huge that the time taken to compute all those, it's a lot.
Yeah.
Like it's not at par with the rate at which it is coming.
Yeah.
So that is one of the bottlenecks, and the reason why that is a bottleneck is the algorithms running behind it.
Yeah.
So algorithms need to be improved a lot.
Yeah.
Okay, they need to be optimized in a much more better way, so that they are able to handle all that.
Okay, so basically, I think even when we are working on I think Hadoop, the capability to really understand that I have a operation which utilizes data which is stored in multiple location, because one location might not have that space, or might be for availability reason you have kind of done that. So that will be actually the only way to solve it. Like you might not really store everything at once. It will be stored in a different environment, chunks, like HDFS file system. And on top of that, you have, but then from a developer perspective, the complexity of understanding how it is stored and then write the algorithm like that will be like near impossible. So therefore, I think we have the technology like Spark, which allows the guys or developers to have an abstraction layer between big data. They're just kind of implementing a machine learning. They don't know how the data is stored or how much vast amount of data is. There is they can understand this when they go one level deeper of the layer, and then they are always working on the application layer. If they go to the next layer, they see how the implementation of storage has been done, and from that they can understand basically how the storage is there and maybe optimize more. Yeah. So from application developer level, I think that might not be an issue if you are really considering some of the technologies which are already built like Spark, Big Hive, to take care of the big data architecture.
True.
So this is the two, and the third problem for the future is
the data set. It's like really
large.
Huge.
Yeah.
And storing it is a big challenge
problem
here, because
I think that's a major challenge. Even I think what happened when we were working on those large data sets, then we were getting so much time in just downloading the files that it was taking 1 hour, 2 hours just to kind of get the archived file.
Well, I like to add something more here. Like if you look at the HDFS architecture, it runs on replication. Right? So even if you have say 1 TB of data to process, By default, SDFs replicate it thrice so that they have redundancy, and in case of any node failure, they are able to they don't go up, the job doesn't stop,
True.
but it keeps on running. So if we have a replication like that, then the amount of data we are processing, we need to have threefold space from that.
True.
So that kind of problems are there when you are trying to reduce the time a lot. Then there's always a trade-off between time and space.
Yeah.
So like, since space is more readily available, so we trade off on that and we go for the time. Like, we need to reduce the time, but okay, space is there. Okay, yes, space is there, but in near future it might not be.
Yeah, I think we are going to a state where we are going back to the computer science basics. So there is always like a work complexity, and it is a work complexity equal to time complexity into space complexity.
Yeah.
So you have only two things. If you're trying to have a huge space, then you can reduce the time. If I go to the basic algorithm level as well, if I just talk about sort here, so the quick sort uses more space and has a better performance, but a normal sort will take
Normal
n square,
sort. Yes.
but a quick sort take n log n, and in quick sort, but you are using more space.
More space.
Yeah, so this is a universal truth that the work complexity is always constant. You have to either increase the space, then the time will decrease, and then, or you want to, if you have less space, then the time will take.
It will take much more time.
It will take much more time. So that is the main, in computer science, that is, I will say, universal truth. You have to make a trade-off between that. On top of that, you might not really go into a NP hard problem. So these are some of the boundaries of computer science itself, where some of the problems cannot be solved, like three-circuit problem, traveling salesman problem, which we might have kind of studied in computer science theory in major and minor and graduate, undergraduate. So these are some of the problems where you cannot really solve those problems because as soon as the data increases, the amount of computation it takes.
Goes.
So those problems commonly referred as NP hard problem. We are basically going into theoretical computer science. Tuning machine halting problem will come here, and the concept of automation will come.
Well, we get to know about the bottlenecks when we go to the basics only.
Exactly. Yeah. So I think theoretical computer science has a kind of very importance in this part, because if you can prove it mathematically in the paper that it will work, then and you have done a logical mathematical calculation on it, then it will actually work. All the scientists which are working in like reputed company like Google, Microsoft Research, they actually work mostly on theory, because before that is actually created in reality
it
with
needs
codes.
To be proven that it works.
It's feasible. It can be done. So that is like what is actually stopping like most of the future growth, is like we are in a people are just touching the boundaries of feasibility, what can be done and what cannot be. And whenever there is a outbreak of a new technology or maybe new innovation, it pushes the boundary a little bit. What we can do more. Okay,
like either push the boundary straight head on or find a workaround.
Exactly.
Like parallel computing.
Exactly. So in future, I think with innovation related to much higher hardware capabilities, much better computation capabilities, I think those limitations will be further reducing down. But there will always be bottlenecks. And I think at this point of time, still, even with so much availability of big data capabilities, the bottleneck is still the processing large scale data involved in machine learning and the computation which we have to do on top of that. Okay, so it was like a big statement. So if you have any question, we have last 5 minutes to discuss about it. And if you are interested in learning entire basics about Python, then you can join with our bundles. We are giving you a free coupon, Step Up. You can use Step Up coupon, and it will be
90% off.
90% off
each the bundles, each of the bundles, and the subscription would be like 90% off each month.
Exactly.
Not just first month. So you can go ahead and use this coupon and check out our bundles. They are UI5, Python. We have the mean stack, We
Full
have
stack, I think, Angular, Node, Express,
and MongoDB.
MongoDB. Yeah.
So okay, we are constantly working on adding new courses there. So
Yeah, I
that
think soon we are launching a full-fledged project as well,
yes,
where you will be actually getting hands-on understanding
on multiple technologies, how
exactly.
they all come together and form a beautiful thing.
Yeah. So we will be working and tying up with some of the corporate entity as well to
Yes.
understand how a project of that scale or the futuristic project should be delivered. So if you have very less experience in this technology, then all the learning will be hands-on, and this will
Yes.
be only open for our subscribers, which are premium subscribers, which are paid member of any of the bundles. So you can use this coupon, and you will be also able to get back to us on any questions which you have personal, or any face-to-face interaction if you need, on online calls, Skype call if you are facing difficulties. Then we will be, and our others subject matter experts will be within your disposal to understand or make you help on those initial times where the questions are much more, where you are kind of just understanding, okay, what is exactly things are. Exactly. So I think at this point of time, you can also mail us with your queries if you have. In future also, you can reach to us. For now, our conclusion is Python is the strong competitor for machine learning. It is not dominating because there are other frameworks or technology
too,
like R, and somewhat C++, C++, I think.
C++,
Yeah.
and C. Both of them basically, because too low level, and there
Fast.
are a lot of experts in C and C++.
Yeah.
Now.
And it's kind of quite stable as well, and then backed by like big giants. I cannot name the technology here or company here. So anyway, so thank you for joining us. If you have any question, you can mail at admin@ufscn.com. Thank you and have a nice day. Happy learning.